How did this universe begin? Were we alone in this huge cosmos before the Big Bang? Just some of the numerous questions the scientists have been pondering for years. Like this one, they planned a slew of projects and missions to gather as much information as possible about our origins and the universe we live in, but no technology existed to do it. The James Webb Space Telescope, a large telescope, was then built by scientists and is expected to help us understand the origins of the cosmos. The Christmas Day, 2021 launch of the $10 billion James Webb Space Telescope was both exhilarating and worrisome for the thousands of scientists, engineers, managers, and support staff who worked on the project for almost a decade. The scientific potential of the JWST is vast, and it could provide answers to some of the most fundamental problems in the universe's evolution. But the real question is, can this JWST achieve it? Is it possible that James Webb will be able to see thousands of years into the future? We'll be discussing this in today's video. A new era of astronomy is just around the corner, provided everything goes according to plan. After a nail-biting launch on Christmas Day, the James Webb Space Telescope JWST has launched its mission to capture the birth of the universe. James Webb Space Observatory will be NASA's largest and most powerful space research telescope, exploring the cosmos to learn more about the universe's history from its Big Bang to the birth of alien planets and beyond. The observatory will cost $10 billion. It is part of NASA's great observatories, which comprise the Hubble Space Telescope and two other massive space telescopes that can stare into the universe. One of JWST's primary goals is the exploration of galaxy formation more than 13.5 billion years before the Big Bang, a hitherto unobserved period of cosmic history that formed our universe. As we know it today, according to NASA, JWST was built to observe a time in the universe's history that has not yet been observed before, rather than to study the origins of the cosmos. We prefer to think if the JWST is a successor to the Hubble Space Telescope, rather than a replacement. More than 30 years after its launch, the Hubble Space Telescope has provided us with breathtaking views of the universe and countless scientific discoveries. It is our hope and expectation that it will continue for many more years to come. However, the Hubble telescope's 2.4-meter diameter mirror, compared to a ground-based telescope, limits its sensitivity and ability to observe the faintest objects. This is a limitation. Even though Hubble can observe infrared light, it cannot access the light wavelengths from the very first stars in galaxy. Hubble has capability to observe infrared light. JWST, on the other hand, will be able to do this task for the very first time. We may even be able to observe stars that were generated from primordial material, from the Big Bang, knowing when and how the first stars originated. Soon after the Big Bang is an important scientific subject. And one of the key scientists of JWST, carbon, silicon, and gold, which are essential to life and contemporary technology, were produced in the early stars, but how they did so is still a mystery to us. As a result, the design of this observatory has been influenced greatly by the fact that it needs to be extremely cool to reduce the amount of unwanted background light. It's not just the initial stars and galaxies that will be studied by JWST. Researchers from all over the world can apply for time at this observatory, which is designed to serve a variety of purposes. Infrared observation will allow JWST to see through the clouds of dust that enshroud very young stars, which are impenetrable to the visible light of the telescope. That means it will be able to see directly into star-forming regions, something Hubble hasn't been able to do yet. The findings will shed light on the formation of stars and the systems of planets that orbit them as a result of the collapse of dust and gas clouds. Webb will be able to see further into the universe than Hubble. And it will be far more sensitive. This will allow Webb to go back much farther in time and view the earliest galaxies that formed in the early universe. According to NASA, this telescope is powerful that even if you were a bumblebee 240,000 miles away, the distance between Earth and the Moon, we could see you. That's what NASA's Goddard Space Flight Center senior project scientist, John Mathis, said. What in the world is going on here? Science instruments on board. The JWST will be able to observe in the visible, near-infrared and mid-infrared wavelengths. Respectively, the wavelengths of infrared light are longer than those of visible light, but they are shorter than those of radio waves. NASA at Goddard Space Flight Centers. Paul Gaither argues that there are numerous reasons to study in the infrared and that the James Webb Space Telescope is no exception. As the universe has grown older, the ultraviolet and visible light emitted in its early days has been stretched and is now reaching as this infrared light over 13 billion years after it was first released. As soon as the first rays of light begin to appear, Webb will be ready. More than 2 decades ago, when the first ideas of JWST were being debated, only the planet in our own solar system were known. Scientists have now found thousands of planets orbiting different stars in the Milky Way throughout this period. It is expected that a considerable portion of the JWST monitoring schedule will be devoted to studying their atmospheres in comparison to Earth-based observatories. JWST's wavelength coverage is particularly well suited to brief searching chemicals in extraterrestrial atmospheres and the lower infrared background from space. There are two ways to go about this. One can take advantage of a dip in the star's light caused by planets passing in front of it, a transit before and during transit. We can discover the composition of the planet's atmosphere by analyzing the light split down by wavelength with remarkable precision. Coronagraphs can be used to obscure the light from the parent star, allowing direct imaging of a planet and its atmosphere or surface to be studied. This could reveal whether a planet is suitable for life, which may necessitate further investigation and deployment of many space probes there in the future. An ideal outcome would be to discover an Earth-like planet, but this would necessitate an extremely favorable set of circumstances due to the planet's rarity in the solar neighborhood and their obscurity in comparison to their parents, star Jupiter, Saturn, and Uranus and Neptune, may be studied by JWST, but is more likely that it'll look at ice giants like those in our own solar system. All of the planets in our solar system are in orbits far closer than our own, and their atmospheres are far hotter and more volatile than our own. Another possibility is that the stars and planets are born ensuring gas and dust clouds because infrared light can pass through clouds. We can see what's going on up there until now. We don't know how the universe developed from a simpler state of hydrogen and helium to the universe we observe today, but the Webb telescope will help us answer these critical issues. The first galaxies will be discovered using near-infrared surveys, followed by low-resolution spectroscopy and photometry. In the mid-infrared, researchers will need to use high-resolution near-infrared spectroscopy to observe things that have never been seen before. The James Webb Space Telescope will benefit from this. So perhaps it will assist us in discovering the truth about our own existence. What are we going to do with this great telescope, asks John Mather. We're going to take a look at everything we can see in the cosmos. We want to know how we got here. He added, how did the Big Bang occur? So we'll take a look. Although we have theories and predictions, we can't say for sure. JWST's science goal is broken down into 4 distinct parts. The rionization of the atmosphere at dawn, putting together a galaxy, origins of life and the formation of stars and planets. Observations of our solar system will be possible with JWST. In addition to investigating planets outside of it, the outermost regions of the solar system, it will be able to identify and characterize comets and other frozen bodies being so far away from Earth's atmosphere. These objects may still be relatively unmodified from the time of their formation, which means they could hold information about Earth's early history, including the origin of the planet's water. However, there will be unexpected discoveries, even though exoplanets were considered science fiction. When Hubble launched, they became one of the telescope's most important goals. When it is put into use. Is it possible for the James Webb Telescope to witness the creation of the universe? JWST, researchers from all over the world can apply for time at this multi-purpose observatory. JWST's infrared observations will enable it to peer through clouds of dust that envelop very young stars and are invisible to the telescope's visible light. This means it will be able to peer directly into regions where stars are forming, something Hubble has not been able to do. The findings will shed light on how stars and the systems of planets that orbit them are formed as a result of dust and gas collapses. The Webb will eventually be able to peer deeper into the universe than Hubble. Furthermore, it will be considerably more sensitive. This will enable Webb to travel much further back in time and observe the very first galaxies to form in the early universe. According to NASA, this telescope is powerful enough to see a bumblebee from a distance of 240,000 miles, the distance between the Earth and the Moon. That is what NASA's Goddard Space Flight Center's senior project scientist, John Mathis, stated. What is going on here? On board, there are scientific instruments. The JWST will be capable of observing in the visible, near-infrared, and mid-infrared regions of the electromagnetic spectrum. Infrared light has longer wavelengths than visible light but shorter wavelengths than radio waves, NASA Goddard spacecraft, and light centers. Paul Geithner argues that there are numerous reasons for infrared research, and the James Webb Space Telescope is no exception. As the universe has aged, the ultraviolet and visible light emitted in its early days has been stretched to reach this infrared light over 13 billion years after it was first released. Once the first rays of light appear, the Webb will be ready, as it was more than 2 decades ago when the first JWST concepts were debated. There was knowledge of only one planet in our solar system. Scientists have discovered thousands of planets orbiting various stars in the Milky Way during this time period, and it is expected that a significant portion of the JWST monitoring schedule will be devoted to studying their atmospheres. In comparison to Earth-based observatories, JWST's wavelength coverage is particularly well-suited for searching for chemicals in extraterrestrial atmospheres and the lower infrared background from space. This can be accomplished in two ways. One can take advantage of a dip in the star's light caused by planets transiting in front of it, both before and during the transit. We can determine the composition of a planet's atmosphere by performing a high-precision analysis of light split down by wavelength. Coronagraphs can be used to block out the light from the parent star, allowing direct imaging of a planet's atmosphere or surface. This could reveal whether a planet is habitable, necessitating further investigation and the future deployment of numerous space probes. A desirable outcome would be the discovery of an Earth-like planet, but this would require an extremely favorable set of circumstances due to the planet's rarity in the solar neighborhood and their obscurity in comparison to their parents, the stars Jupiter, Saturn, Uranus, and Neptune. This may be accomplished by JWST, but it is more likely that it will look at ice giants similar to those in our own solar system, as all of the planets in our solar system orbit at much closer distances than our own. Another possibility is that stars and planets form in the presence of gas and dust clouds, as red light can pass through clouds. Until now, we can observe what is occurring up there. We do not understand how the universe evolved from a simpler state of hydrogen and helium to the universe we observe today, but the Webb telescope will assist us in addressing these critical questions. Near-infrared surveys will be used to discover the first galaxies, followed by low-resolution and optometry in the mid-infrared. Researchers will need to use high-resolution near-infrared spectroscopy to observe previously unseen objects. The James Webb Space Telescope will benefit from this. Thus, it may aid us in establishing the truth about our own existence. What are our plans for this magnificent telescope? John Mass inquires. We're going to examine everything visible in the universe. We're curious about our origins. How did the Big Bang happen? He added. As a result, we're going to investigate. Although we have theories and predictions but cannot be certain, JWST's science objective is divided into 4 distinct components. JWST will be able to observe the ionization of the atmosphere at dawn, the formation of stars and planets, as well as the origins of life and the formation of stars and planets. Along with investigating planets beyond it, in the solar system's outermost regions, it will be able to identify and characterize comets and other frozen bodies due to its proximity to Earth's atmosphere. These objects may have remained relatively unchanged since their formation, which means they could contain information about Earth's early history, including the origin of the planet's water. Despite the fact that exoplanets were considered science fiction, there will be unexpected discoveries. They became one of the telescope's primary objectives after the Hubble was launched. It is put to use when it was. Is it possible that the James Webb Telescope will witness the universe's formation?